So ways to synchronize the process in a Python will be there. So there are multiple ways to synchronize the parallel process environment will be there. The first one is lock. So lock is a defined method which is available inside the threading library, where you have two principal method. One is called as acquire. Suppose if a process wants to access a resource, that is it want to lock the premises, then you can call the acquire method, which means that the resource is currently used by that particular thread will be there. So when someone is trying to access the resource, it results in waiting conditions will be there. Once the task completed the accessing resources, then it will call the release method will be there. Once it is released, it will be available for other resources. A lock have prominently two states will be there. One is locked and unlocked will be there. So once you call the acquire method, it turns to a locked state. Once it is called the release method, it will be moved into an unlocked state will be there. Second one, re-entrant lock. It is a specific kind of a lock will be there, which primarily allows for the same thread to enter multiple times. See, inside a lock, if a process is accessing a resource, the same process will try to access the resource again. It will not be allowed to access will be there. That is a major issue which will facing in a locks will be there. That can be eliminated using a re-entrant locks, which allow the same process to access the resource at multiple times will be there. So R lock is nothing but a re-entrant lock. Class is a version of a simple locking that only blocks if the lock is held by another thread, which means that it allows same process or thread to access the resource multiple times will be there without any problem will be there. If someone new thread which is trying to access the resource, that thread will get blocked by the re-entered lock will be there. Third one is semaphore, which is an internal counter rather than a lock flag, which will it blocks only more number of given threads trying to attempt. That is, if you set the counter is 5, ultimately 5 threads will be allowed to access the resource. If the range is increasing from 5 to 6, ultimately it's try to stop the accessing resource only. At any point of time, the given number of threads can be allowed to access the resources will be there. Lock in Python, synchronizing using locks will be there. So as I said, lock have two states, which is locked and unlocked will be there. That can be manipulated using your methods acquire and since release will be there. If a state is unlocked, you can call the acquire, which change the state to locked will be there. If a state is locked, you can call to acquire blocks until another thread called the releases will be there, which means that thread is already holded by one process will be there. That specific process will has to call the release method. Once it is called the release method, your thread state will be changed to unlocked state will be changed to unlocked will be there. If a state is unlocked, call to release raises an exception because it is already released, so you cannot claim release again will be there. If a state is locked, call to release changes the state from locked state to unlocked state, the same which has been explained in a diagrammatic will be there. Synchronize in Python using logs will be there, right? So I have defined an increment counter, right? While trying to access the global value, before manipulating a value, I just create a log method. Once log is acquired, no process will allow to access that specific part will be there. So ultimately what happens, the counter will get incremented from 1 to given range 100 will be there. Once it is incremented to 100, ultimately the log get released will be there. And the second thread, so ultimately decrement thread will go to the value, it access the value and it check the lock. If it is lock is released, ultimately it acquire the lock will be there, and it will once the lock is acquired, it is held by that decrement thread will be there. So it will decrement the value counter currently until it reaches the 100 iterations, and once it reaches 100 iterations, the lock will get released will be there. So we are creating a thread T1 which is used to for incrementing, and T2 for decrement will be there. We'll try to call the both threads and use the join operation will be there. We'll see the execution of the program. So raise using lock will be the same program which you have seen previous. So x equal to 0, count equal to 100, lock equal to threading lock, which will create a lock. You can acquire a lock, that is you can change the unlocking state to lock state using acquired, and you can call the release method which will be unlocked, your thread will be there. So access a global variable, before increment a counter I'll put a lock, acquired will be there, and I do the process. Once the process completed, I call the release method which will release the state of thread will be there. Similarly for decrement will be there. Then we'll try to create a two threads and call the join, start and join will be there. I'll run the process. If we see the execution of a process, so initially thread will be started and incremental counter will be increasing. it start from increasing 1 to 100. The thread releases the start, current value of x will be 100, and the second thread we try to access will be in a waiting stage till then, so it will be 99. It will be decreasing order until it reaches the values will be there. So in earlier case you will find there could be a mix of values will be there. You cannot define the value, one thread accessing, other thread will be accessing at the same time, which will result in a invalid behavior will be there. So here the behavior is defined in an order. So first thread will try to increment till incrementation is completed, that other thread will be blocked. Once it is released, the second thread, decrement thread, will be allowed to access and will run the process continuously. Right. This is the first way for using synchronization. Second, reentrant lock will be, as I said, reentrant lock is nothing but a specific type of lock which allows the same process to access the lock multiple times. If any new process will try to access, that will be put into blocks. So here I'm defining a class, right, inside which I'm creating a lock of type rlock will be there. Right. I'm having an add method will be there. Before trying to add a variable, I'm just using a lock will be there, right? So and once it is locked, the value will be incremented. So every method will have a lock method will be there. So the same process, which is nothing but a foo, which try to create a lock for multiple times, same process will try to acquire, which means that this process does not have any issues will be there. It can increment as. And the second, I have defined a two more method which is called as adder and subtract will be there, where you are trying to call the increment decrement functions will be there. Let's see how the behavior of reentrant lock will works. The same program rlock will be implemented using threading.rlock will be there. We'll try to create a lock before the value get access will be there, and whenever you want you can release the locks will be there. So third approach for synchronization will be using semaphores will be there. So semaphore is a programming construct which will allow to access the process for a specific number of times will be there. So to import semaphoring, you can use threading.semaphore will be there. So import threading, import time will be there, done equal to threading.semaphore. That is, we are initializing the semaphore to 0. We have two process. One is producer, which trying to produce a product will be there. Once it is produced, it's put to sleep for some time. Once it have a mechanism which is called as release, which means that semaphore is released once it is accessed the item. In the consumer side, we are trying to acquire and consume the items will be there. So it has signaling mechanism which is used in the producer consumer problem here. So producer will produce a product and release the product so that it is available for the consumer, and the other end consumer will consume the product. Before consuming, it's called the acquire method will be there. Essentially, producer will access the data. Once it is produced, it provide information to the consumer. Consumer is acquiring a log, and it will consume the data will be there. So in this we are using semaphore approach. We are creating a semaphore from the threading library, and once the process is ready, it will provide a signal using a release method. Once you want to access the process, you can use the acquire method, which is acquire the resources will be there. Until you acquire the log, it will be put into waiting mode will be there. That is, consumer is waiting to acquire resources. Once a resource is available, if you call release, it will provide a signal to acquire. Once it is acquired, it consumes the items will be there. So synchronizing using event mechanisms will be there. So event is, so you have a class which is called as event, which is inside a threading library will be there, which allows you to provide signaling between two different processes. That is, you can use inter-process communication between two different processes will be there. Here you have two different thread. One is a worker thread, the other is a producer thread will be there. So where we are trying to use the messages communicate between the process will be there. Available dot acquire, which means that before accessing a resource, we'll call the acquire method, and there is a signal method which is on the other side. Available dot release will be there. When the product is available, it provide a signal to the other end, so that other process will be accessing a resource will be there. A producer is producing an item, worker is consuming an items will be there. So both processes are communicating through using event mechanisms will be there. That is, completed set, completed wait will be there. It is waiting and set methods will be there, and you have acquired and release methods will be there. Same example using a producer consumer will be there, where we have one set of queue, which is a common resource which is shared between two processes. Both processes will be operating on the same queue will be there. One will be adding items to the resources, other will be removing item from resources will be there. So each process will works parallelly will be there. So make sure that it does not have an issue will be there in concurrent accessing will be there. To achieve that, we are trying to use the synchronization mechanism. That is, you can use the sleep method, where threads will be put into sleep method and accessing the resources parallelly.